Howdy and welcome to my video on logarithms. In this video, I will be doing practice problems that will cover various concepts involving logarithms. These problems are from the Virtual Math Learning Center, and a link to these problems we put in the description. I will be skipping some questions because those questions are more generic graphing questions. So I will keep one question, but I will not do all of them. If you'd like to see those excluded questions, you may look in the link I put in the description. All right, so for question 1, we're to simplify without a calculator. And that's fine, okay? So log 464, right? We're being asked for part A, 4 to what power is 64, okay? 64 is 4 power 3. So the answer to this is 3. Okay. For part B, 7 log 7, or 7 log base 7, 4, right? Plus 2. Same base in the log, so it cancels out, and you get 4 plus 2, and that just gives you 6. For part C, we have log 10 negative 5. Okay. When log is shown without the base, it's base 10, right? Same base, and all you get is the exponent, so negative 5. Another way to think about this is if you did the exponent law first, you get negative 5 log 10 10. And this is just 1, so you get negative 5. So answer part C is negative 5. Okay. Now part D looks like we're gonna solve for solve for x, right? We have the same log base on both sides, so we can set the arguments equal to each other. We'll simply get 3x plus 5 equals 9. 3x equals 4, x equals 4/3. And if we plug it in, make sure we have a valid answer. We get log base 11, 4 plus 5, which is log base 11 of 9, and that is all good. So x equals 4/3. Okay. I'm just going off the Math Learning Center. We solved for x, but if you were strictly simplifying, we're just here. Okay. So the other part D, I'll put it right here. So we have log 11, 3x plus 5, and we'll move the other log 11 to the other side like this. Wait, no, sorry, never mind. We can't do that. I'm just going to move on to question 3, okay? So, question 3, we're going to choose a graph that best matches a function given. So, you'll notice 2 things, okay? 3 things. One is this reflection across the x-axis. This is left 5, and this is up 2, okay? So I'm just thinking, the parent graph for log of x, okay, looks something like this. So if we do this reflection first, right? So if we first do this, we get something like this, okay? I guess it's more like it'd be more like this. There you go. Okay. If we reflect first, and we'll get something like where is it? kind of like this. All right, trying to see where we go. Kind of like this, okay? If we go left 5, right, then, oh, I need to move this graph over. Okay, if we go left 5, right, so we do this next. We're gonna end up on this side instead. Right, so we moved over, have an up 2. We'll just be going up just a bit. Probably still go somewhere through this axis, I'm not quite sure. Okay, so this purple graph is what we want to see. And it looks like the dark blue is the most likely to be our graph. This yellow, right, it's flipped on the y-axis, as you can see, but we don't have a negative in here. That's wrong. The red, right, there's no reflection on the red, so that's wrong. And then for, I don't know what happened to this blue one, but I think that is just a y-axis reflection without the x-axis, so that is also wrong. Okay. All right, so yeah, I'm gonna name this question 1. Okay, so this is Q1. This will be question 2. This way, sanity. Okay, so question 3 now. Okay. Use the properties to expand as a sum, difference, and or constant multiple logarithms, and assume all variables are positive. Okay. This line is important because that means we don't have to deal with any restrictions. Okay. So first off, I'm going to split this as a sum. So a product of 64 and x squared. So we get log 4 64 plus log 4x squared. Okay. The log 4 64 can be simplified as just positive 3, right? And then we can move this 2 over to the first coefficient using another law. So we get 2 log base 4 of x. And that is our answer. For question 4, oh, that's bad. For question 4, right, we again expand to a sum, difference, and or constant multiple of logarithms. Again, the positive note to make sure we don't have to deal with restrictions. Okay. So first, I'm going to rewrite it so it's natural log x squared over x squared minus 8x minus 20. Instead of cube root, I'm going to do a 1/3 exponent. This way I can move this over here, and we get 1/3 natural log x squared over x squared minus 8x minus 20. From here, I would use the division law. Actually, I won't use it quite yet. I want to factor out that numerator real quick. Okay. I'm looking for 2 numbers that multiply up to -20 and add up to -8. This is -10, +2. I'll rewrite as this. Okay. We can take an x out from the left 2 terms. Get x times x plus 2. Take out a -10 from the right 2, and get x plus 2. Common factor goes out, and we add the rest. Okay, so this is our denominator. So we get 1/3 natural log x squared over x plus 2 x minus 10. Now from here, we're going to use the fraction law, right? So 1/3 natural log x squared is in the numerator, so we will keep it positive, but the whole term positive, that is. X plus 2 is in the denominator, so it's a minus 1/3 natural log of x plus 2. X minus 10 is also in the denominator, So it will also be a negative 1/3 natural log x minus 10. This 2 can still move in front, so we get 2/3 natural log of x minus 1/3 natural log of x plus 2 minus 1/3 natural log x minus 10. And there you go. That is your full answer. These cannot be separated because you're adding. They cannot be, there is no law when you're adding two things together, okay? All right, for question 5, instead of expanding out, we're combining in, okay? So we want to condense everything to one logarithm. So we look at this, right? So we have same base, so that's a good start. This minus 1, right? This is just log or minus log 5, okay? Because 5 power 1 is just 5. Sorry to scratch something. Okay, so I'm gonna rewrite. So you have 2 log 5, right? X minus 1 plus 4 log 5 of y minus log 5 of 5. I'm going to first move these coefficients into the exponents. So we get log 5 x minus 1 squared plus log 5 y to the 4th minus log 5. And now we'll use good old multiplication division law, right? So log, or the addition subtraction, right? So log 5, so x minus 1 squared is positive, right? There's a positive implied here. So we had x minus 1 squared on top. The y to the 4th is also positive, so bring that up. The 5 is negative, so bring that down, and you get this. It doesn't ask to simplify, so this should be a-okay. If you wanted to simplify, right, you could do this would be a log base 5, and you would have x squared minus 2x plus 1 times y to the 4th over 5, and that is log base 5 of x squared y minus 2xy, oh, sorry, to the 4th, right, 4th plus y to the 4th over 5. Okay, now for question 6, again, we are condensing everything together. Condense the expression as a single logarithm. So let's begin. So we have 2 natural log 6 minus natural log 8 minus natural log 81. I'm going to first move this into the exponent. So we get natural log of 6 squared, which is 36, minus natural log of 8 minus natural log of 81. Now we can do natural log of, so 36 on top, because the logarithm is positive, then 8 times 81 on bottom. And if we simplify that, let's see, and divide by 9 on top and bottom, so you have 4 over 8 times 9, divide by 4 again, by 4, you get 1 times 2 times 9, it's 1 over 18, okay? So this equals natural log of 1 over 18, and that could be your final answer, right? If you want to take it one step further, you can do, this is natural log of 18 power negative 1. So it's negative natural log of 18. Either way, both answers are valid according to the question. Okay. So number 5 is change this logarithm to base 5. So every time you do a base change, right? So you have a log on top, a log on bottom. The new base will become the base of the log, okay? The top part, the numerator, is always your argument. And the old base will be the argument in the denominator, okay? That means it is log 5 45 on top and log 5 of 7 on bottom. Now, you can simplify this down, right? This is log 5 of 9 times 5 if a log 5 7. So you get log 5 of 9 plus log 5 of 5, right? For log 5 of 7. And this gives you log base 5 of 9 plus 1 over log 5 of 7. And this will be your final answer. Okay. Now, technically speaking, right, this right here could be your answer because we have it at log 5, log base 5. Okay. Number 6, not number 6. This is question 7, right? So we're on question 8. Change log base 6x to base 10. So again, right, argument goes to numerator, base goes to denominator. So this is just log base 10x over log base 10 6, and you can also just write log x log 6, because if you don't write out the base for log, not natural log, right, it's implied to be base 10. And these would be your answers. And with that, that concludes my video on logarithms.